Hello all. In this lecture we'll see about for loop. So we have already seen two types of repetitive statements. First one was while loop and the second do while loop. Now we have one more looping statement. It is known as for loop. So we'll see the for construct in this lecture. So it is a determinate or definite loop. For construct is also known as a determinate or definite loop. So the meaning of this is the programmer knows exactly how many times it will repeat. So in the case of while or do while, we are not sure how many times it will be repeated. It is based on that test condition. But here we can mathematically calculate the number of times a loop will be repeated. So number of repetitions can be determined mathematically in the case of for loop. Okay, so that's the main difference between this for and the other loops. So in the case of while and do while, we may not be able to predict the result always, but here we can say mathematically calculate how many times it will repeat. So we will see the syntax, for syntax. So this is a for syntax. For, this is the keyword, and within brackets we have initialization. There will be some expression for initialization, uh, and it will be separated by semicolon. Then text expression, and we have a semicolon here, and we have an updating session. There is no semicolon, and it will close the brackets, and within this braces we can write a statement or any number of statements inside this. So this is the syntax of for loop. So we have initialization. So we have three parts in the for loop, or we can consider it as four part. The first part is initialization, second is test expression, and third is updating, and fourth we have the set of statements or the body of this for loop. Okay, so we'll see one by one what is this initialization. So initialization, it is a part of the loop that is executed first. So whenever it reaches a statement, the first part to be executed will be the initialization thing. So it will be executed first, and this will be executed only once. So this will be executed only once. So we have already mentioned that loop is a repetitive statement. So it will iterate. But in the case of for loop and in the case in for loop, the initialization statement will be executed only once, and it will be executed first. Okay. Then we have the second part, that is a test expression. So it is separated with a semicolon. Okay, test expression, and text expression must be true for the loop to continue execution. So this test expression, it is based on this test expression, the loop will continue its execution. So if you consider that while or do while, we have a condition. So whenever that condition is true, that loop will be executing repeatedly. Similarly, here this text expression. So it is an expression. It can be any kind of expression, and whenever that expression is true, the loop will continue executing the statements. Okay. Then we have the third session, that is the updating session. Updating session, it is actually to execute it every time through the loop before the loop condition is tested. Okay, so it will be executed every time through the loop before the loop condition is tested. That is, the before executing this test expression, we will be updating. Okay, so how it works, we will see with an example, then you will understand. So I'll show an example. So we'll see the while loop first. So we have already seen this program to print of hello 5 times. So we have initialized I equal to 0. Then we'll check while I less than 5. So 0 less than 5. 0 is less than 5. It will print hello. After that, what it does, we will be updating the I value. So I will be incremented by 1. So I becomes 1. Then again after that, this condition will be checked, 1 less than 5. So it is true. Again this printf hello will be printed. Again I value will be incremented again. I becomes 2. Again we'll check the condition, 2 less than 5. It is true. So it is again printed. Like that 5 times it will be printed. So we have seen this while loop. So we can replace this while loop with a for loop. So this is the equivalent for loop. So we are not initializing I here. We are simply declaring I here. So we have initialized here. So this is a for loop, and the first part of for loop is initialization. So we'll be initializing inside here. So I equal to 0 and a semicolon. So this is the initialization part. Then this is the text expression. So we have a condition here, that same thing will be done here also, I less than 5. Then we have an updating session. So updating session, so after printf, what we in the while loop, we are incrementing it. So we will bring this I plus plus here. So we will be updating it here. So, and only one statement will be there in the body of the for loop. So that's the difference between while and I. So this both will be same. So how this execution happens, we will see how this will happen. So this statement will be executed in I will be declared as integer. After that, for loop, we have already mentioned, there is the initialization text will be executed first, and it will be executed only once. So I will be initialized to 0, and after I is initialized to 0, what it does is, in the first step, I less than 5 is checked. So 0 less than 5. So it is true. So since it is true, it will be executing this printf statement. Printf hello will be printed. Okay. After printf hello will be printed, what it does is, it goes to this section I plus plus. So I becomes 1. So after I is made 1, it will go again and check the condition here, 1 less than 5. So it is true. Again printf hello will be printed for the second time. Then after printing this, again it goes here. I will be incremented to 2. Again it will check the condition 2 less than 5. So it is true. Again this statement will be printed. A third time hello will be printed. Then I will be incremented again. I becomes 3. So 3 less than 5 will be checked. This test expression will be checked. 3 less than 5. So it is true. Again printf hello will be printed for the fourth time. Then I becomes 4. Now 4 less than 5 will be checked. It is true. So again fifth time hello will be printed. Then I becomes 5. Then the condition will be checked. 5 less than 5. So it is false. Since it has become false, it will exit the loop. It goes to the return statement. So this is the way the for loop exists. So first I equal to 0 will be initialized. After that, the condition will be checked. If it is true, this will be executed. If it is false, then it will not execute the statement. It will go out of the loop. Okay. Then the condition is checked. After that, printf hello will be executed. After that, we will be updating the value. So that is what happens here also. We will be updating the I value. So this I updation will be done inside this brackets. Okay. Then after that, the condition will be checked. Printf hello, like that, this will be going on. So only once this I equal to 0 will be executed. So we will see the steps. So this is the same for loop we are taking. The first step will be set I equal to 0. So that is what is happens here. After that, if I is less than 5 is checked, if I is less than 5 is checked, then execute the body of the loop. That is printf, this statement will be executed, and go to step 3. We will see what is step 3. So if I not equal to 5 or not less than 5, then otherwise go to the next instruction after the for loop and continue. So if this is false, if this condition is false, then the body won't be executed, but this statement will be executed. That is outside the for loop will be executed, and the operations will be continued. So what happens in step 3? So after printing this, what happens? We will be incrementing this I. Then after that, what it does is go to step 2. So step 2 is again the checking of this condition. Okay, checking of this condition, and if it is true, this will be executed. Again, increment I, then the condition like this, print, then increment, condition, print, increment, condition, like that. This will go on until the condition becomes false. Okay, so these are the steps of for loop. So this is very important, because for loop will be used throughout every program that will be studied in later sessions also. So you should understand this for loop thoroughly. I will be talking about the variations of this for loop also. So we will see the flow chart of this for loop. So for loop, first step is initialization. So I equal to 0, that initialization will be done. Then after that, the text expression, that is the condition, will be checked. If it is true, then what happens? The statements will be executed. After executing the statements, we will be updating the value, that is increment I will be done there. Then after that, again, sorry, there is a mistake here. Okay, sorry, there is a mistake here. So after updating, it won't be going to initialization. After updating, it will be going to again text expression. So text expression will be evaluated here. Sorry, I made a mistake here. So after updating, again the condition will be checked, and if it is false, then it will exit the loop. If it is true, it will execute the statements. After that update, again test expression. There won't be any initialization again. Initialization will be done only once. So this is wrong. Sorry for. So we will see the variations in this for loop. We will see before that we will see some examples of this for loop. Okay. So vim for dot c. Okay, it is not there. Vim for one dot c. So this is a simple program. So we have already seen this. So int I, we have already seen this example. So this is the initialization section, I equal to 0. So then the test expression will be checked, 0 less than 5, it is true. So hello world will be printed. After that, I will be incremented to 1. Again test expression, 1 less than 5. So 1 is less than 5. So hello world again will be printed. Like that, it will be going on repeating 5 times. Okay, we have already seen this program. So GCC for one dot C dot slash A dot out. So we can see that 5 times the hello world will be printed. So 5 times that hello world will be printed. Okay. Now we will see another example for 2.c. So this is another example. So we have a variable a that is declared here. Then initialization a equal to 10 will be initialized. A is initialized to 10. So it is not necessary that you should initialize to 1 or 0. You can initialize to any value. Here it is initialized to 10, and then the condition will be checked, 10 less than 20, so it is true. So what happens, this printf will be printed. So value of a is here percentage d, that is 10 will be printed here. Then after that printf statement, a equal to a plus 1. So it is not necessary you should have a plus plus. You can have an expression like this, a equal to a plus 1. So a is incremented by 1. So a becomes 11 and it is assigned to a. So 11, then the condition will be checked, a less than 20. So 11 less than 20, it is true. So again the value of a is 11 is printed here. Then after that a becomes 12, 12 less than 20. So value of a is 12 will be printed. Like that it will go on up to 19. Up 10, 11, 12 to 19 will be printed. So we will see this example. We will run this GCC for 2.c dot slash dot out. So you can see that value of a 10, 11, 12 up to 19 it will be printed. When it becomes 20, the text expression becomes false, so the loop will be exited. Okay. We will see one more example. Sorry. For 3.c. So this is another example. So this is actually, we have already seen this program. It is to find the sum of n natural numbers. So if we give 5, we will get the answer 1 plus 2 plus 3 plus 4 plus 5. Okay. So here we are declaring some variables ni, and sum is initialized to 0. Then the user is asked to enter a positive integer and it is stored in n. So if user enters 5, n becomes 5. Okay. Now we have this for loop for I equal to 1. So here I is initialized to 1. Then 1 less than or equal to n is 5. So 1 less than or equal to 5, it is true. So what happens? The sum value is incremented. Sum is I value is added to sum. Sum plus I is done. So this is sum plus I, and it is assigned to sum. So sum is 0, 0 plus I is 1, 0 plus 1, and sum becomes 1. Then after that, I value is incremented here. So I becomes 2 now. I was 1. Now I becomes 2. Then the condition is checked. 2 less than or equal to 5. So it is true. So again this will be done. Sum becomes 1 plus 2, that is 3. Sum becomes 3. Then I is incremented again to 3. 3 less than or equal to 5. It is true. So sum becomes uh, it was 3 plus 3, it becomes 6. Like that it will go on repeating until I becomes 5. So when I becomes 5, until I becomes 6. When I becomes 6, 6 less than or equal to n is false. 6 less than or equal to n becomes false. So the this statement will be printed. Printf sum will be printed. So this is the program. So dot slash, so I have already compiled it, dot slash a dot out. So enter a positive integer. So if you are entering 5, you will get the sum as 15. So 1 plus 2 plus 3 plus 4 plus 5 is 15. So we have already seen this example. So if we give 10, it will be 55. Okay. Okay. So that's all. Then we will see one more example. So Vim for 4.c. So this is a program to find the factorial of a number. So to find the factorial of a number, so we have declared two integers I and n. Then factorial variable is declared as long int. So fact, and it is initialized to 1 also. Now here you are entering, the user is asked to enter the number and it is stored in n. So if you enter 5, you will get 5 factorial. So 5 factorial is 1 into 2 into 3 into 4 into 5. So here I equal to 1, it is initialized here. Then after that 1 less than or equal to 5. So it is true. So fact into 1. So fact is initially 1. So 1 into 1 is 1 and it is stored in factorial. Fact becomes 1. Now I is incremented. I becomes 2 now. Then 2 less than or equal to 5. So it is true. So 1 fact into 1 I is done. Fact was 1. Now fact 1 into 2, it is 2 and fact becomes 2. Then after that I is incremented again. I becomes 3. 3 less than or equal to 5. It is true. Then fact is 2 into 3, that is 6. So fact becomes 6. Then I is incremented again. I becomes 4. 4 less than or equal to n. Like that it will go on repeating until I becomes 6. Okay. So the finally we will get the factorial in fact variable. After that, when it becomes false, this printf statement will be executed. Factorial is percentage %ld because we have declared as long int. So fact is a long int. So we will be using percentage %ld. Okay. So we will run this program. So gcc for 4.c. So you can enter any number. So 5 factorial, it is 120. Okay. So if you want to enter any other number also, you can get 6 factorial is 720. So any factorial you can get it using this method. Okay. Now, so that's all about the basic for loops. Now there are variations in this for loop. So we will see different variations and an example for each of this loop. So you should understand this for loop thoroughly. That's why I'm telling about all these variations also. So first one variation is multiple initializations. So we can do multiple initializations uh, in the same in the for loop. So for loop, first part is initialization. So in that for loop, we have only initialized a single condition. We have either initialized I equal to 0 or I equal to 1 like that. So we can have multiple initialization and all initializations should be separated by a comma operator. So you should use a comma operator for multiple initializations. Okay. So we will see an example here. Then you will understand the program. So vim for 5.c. So this is the same program. We have already done 1 plus 2 plus 3 plus 4, 5. So sum of n natural numbers. This is the same program. So only difference is in the previous program we have initialized that sum equal to 0 initial stage itself. So we are not initializing that sum equal to 0 here. Instead what we are doing is we are initializing that sum equal to 0 also here and I equal to 1 also here. Okay, so there are two initializations happening here and they are separated by a comma operator. So we know that the first part of is the initialization part. Initialization happens gets executed only once. So whatever initialization you want, you can include in the for loop because some variable is used only inside this loop, and instead of initializing it here, we can initialize here also. So multiple initializations is possible in for loop. So that's the first variation. So that is this is an example for this. So nothing happens. You can run this program also. GCC for 5.c and dot slash a dot out. You can see that if you run this and if you enter a number, you will get the first sum of first five numbers. So multiple initialization is possible. Okay. Then the second variation is initialization can be skipped. That is, if initialization is not required, the first part is not required, or the initialization is done before the for loop, the initialization can be skipped, but we have to include that semicolon. Okay, so if we have initialized it before itself, we need not do that inside the for loop. Okay, we will see an example, then you will understand why this happens. So for 6.c, sorry, vim for 6.c. So this is the same program. So in the previous program, I equal to 1 and sum equal to 0 was initialized inside the for loop. So instead of doing that, we are initializing it outside. So we are initializing it I equal to 1 and sum equal to 0 here. And if you see the for loop, there is no initialization part here. Okay, there is no initialization part here. So there is no initialization part here, but the only thing is we have to include that semicolon here. This semicolon should be present here. Otherwise, it will become an error. So this semicolon is important here, but this initialization part is vacant. We have not included anything because we have already initialized I equal to 1 and sum equal to 0 before the for loop itself. So it is not necessary that we have initialization here. So because initialization will be executing only once. So it has already been executed outside. Now when we check I less than or equal to n, I is already 1. So 1 less than or equal to 5, it is true. So this sum will be 0 plus 1 will be done and some value becomes 1. Then I is incremented. I becomes 2. Then 2 less than or equal to 5. It is true. Again, it goes on repeating like this. So we can skip this initialization. So this skip initialization can be skipped. Only thing is that semicolon should be present here. We know that the three parts are separated using this semicolon. So this semicolon is important here. So I'll run this program. You can see that there won't be any error here. So I have already run this program gcc for.c. Now if you run dot slash a dot out, you can run, you will get the sum as 15. Okay. So that is another variation. So you can, initializations can be skipped. Then third one, updating need not be an increment or decrement operator. So in the previous, all the examples what we have seen is the third part of the for loop, we have either increment or decrement statement, but it is not necessary that it should be an increment or decrement statement. It can be anything that can be used to update. So we will see another example. So vim for 7.c. So this is an example. So this is actually to find the sum of digits. So we have already seen this program to find the sum of digits of a number. That is, if you are giving 123, 1 plus 2 plus 3 will be done. So the result will be 6. So sum of the digits will be found out. So here we have n r variables and some value is initialized to 0. Then you are asked to enter a number. So if you enter 245, then 2 plus 4 plus 5 should be done. So the number is 245 in here. So we have no initialization here. So we have skipped that initialization. Initialization is not required here. Then we will check whether n greater than 0. 245 greater than 0. It is true. So what it does is, we will find the modulus operator. We will find the remainder when we divide by 10. So 245 divided by 10, it is 5. So r becomes 5 and sum is 0 plus 5, it becomes 5. So we have added the 5 to the sum. Now we have to take 4 and 2. So for that, what we have to do is, we have to perform this division. This is actually n equal to n by 10. So n equal to n by 10. So n is 245. 245 by 10 is, since it is integer numbers, n is integer, 245 by 10 is 24. We won't get 24.5. Since it is integer, you know that we will get only 24. Now n becomes 24. Now we will check the condition. 24 greater than 0. It is true. So this will be done. 24 mod 10 will be done. So we will get 4. So r becomes 4. Sum was previously 5. 5 plus 4 will be done. 5 plus 4, it is 9. Sum becomes 9. Then after that, n by 10 will be done. 24 by 10, it is 2. 2 greater than 0, it is true. Then 2 more 10, it is 2 again. R becomes 2. So previously the sum was 9. 9 plus 2 becomes 11. Sum becomes 11. Then we will check the condition. 2, we will update the value of n. N is 2 divided by 10. It becomes 0. N becomes 0. So n, we will check the condition. 0 greater than 0, it is false. So it will exit the loop and sum will be printed as 11. Okay. So here, if you check, it is not an increment or decrement operator. We have included another expression. So we are updating that n value. So that n value will be changed. We will be dividing it. So if we are giving 245, initially it will be, n will be 245. After completing the first step, we will get 24. After that, it becomes 2. After that becomes 0. Like that, it will go on. So we need to update that n value. For that, we can use any expression. Okay. So we will run this program. So gcc 47.c. So you have to enter a number. So if you enter 245, you will get the sum as 11. 2 plus 4 plus 5. So it will be added from this end. So since we do this mod operator, we will get the remainder 5. Then after that, 5 plus 4, then 9 plus 2 will be done. So we will get 11. Okay. So updating need not be an increment or decrement operator. Then the next variation, updating can be skipped. It is not necessary that updating should be there. So that update operation can be skipped also. Okay, updating can be skipped also. So we will see an example, then you will understand how we can skip that updating operation. So we will take the same example. So we have already seen, okay, we will take the same example for 8.c, the same program only. So here the same program to find the sum of digits of a number. So here we have skipped the update operation. So update was n by 10 should be done here. So we have removed that update operation, and that update operation is given inside the for loop. So that is okay, because we have already seen this when this should be executed. So this should be executed before this condition is checked. So this is being executed before this condition being checked. So we can remove this update from here, and we can include it inside the for loop also. So only thing is we have the semicolon. So there is no initialization here. If you want, you can include the initialization sum equal to 0 or some other value can be initialized here. Then only the condition is here. So if you are giving n value as 245, first it will check 245 greater than 0. It is true. So mode 10 will be done. So we will get r as 5. Sum is 0 plus 5 will be done. We will get 5. Then after that n by 10 will be done. This is equal to n equal to n by 10. So n by 10 means 245 by 10, that is 24 will be the result. Then after that, since we have no update condition here, it will check there is nothing here. So then it will go to this here, and it will check 24 greater than 0, it is true. Then again it will go continue this execution. So we can skip this update condition if we are including inside the for loop, or if it is not necessary also you can skip. The only thing is that loop should terminate, because by updating only it will change the end value. Otherwise, if the end value is not changed, then it will become an infinite loop. We have already seen an infinite loop also. Okay, we will run this program. So gcc for 8.c. Now dot slash a dot out, enter a number. So if you enter 245, you will get the same result. Okay, 11 will be got. So that is updating can be skipped. Then multiple statements can be written in the third part. That is, in the updating part, we have only seen a single statement, either I plus plus or n by equal to 10 like that. But we can have multiple statements can be written in the third part. So we will see an example, vim for 9.c. So this is the same example here. Okay, same example. So what we have done is some updation. So some value is updated here, and n by equal to 10 is also done here. Okay, so what happens is, if it is separated by comma operator, what happens is the first statement to be executed. So we have two expressions here. This is the first expression, and this is the second expression in the updating part. So if we have two expressions, if it is separated by comma, then the first statement to be executed, first expression to be executed will be sum equal to sum plus r will be executed. Then after that, n by equal to 10 equal to n by or n equal to n by 10 will be executed. Okay. So this updation. So without in the previous example, we have seen that both these statements were written inside the for loop. Here it was written. So what happens if you are entering 245? First 245 greater than 0, it is true. So n mod 10, that is 245 mod 10, r becomes 5. Now after that, there is no other statement, so the updation will be done. So updation happens in the from left to right. Since it is a comma operator, the first statement will be this will be, it is left justified. So left, the left operator, so left thing expression will be evaluated. So sum becomes 0 plus 5, sum becomes 5. After that, n by 10 will be done 245 by 10, that is 24 will be done. Then after that, n greater than 0, 24 greater than 0 will be checked. It is true. So again, n more 10, 24 more 10. So r becomes 4. Now sum was 5, 5 plus 4, r is 4 now, sum that is 5 plus 4, 9, and sum becomes 9. Then after that, 24 by 10, so we'll get 2, 2 greater than 0, like that it will go on repeating. So we can include multiple updations, multiple expressions in the updation. So we have to separate using a comma operator. So if we are separating with a comma operator, then from left to right the execution happens. So first this expression will be done, after that this expression. So if you are changing the order, then it will become an error. Okay, we won't get the correct result. We may not, in some cases we may not, but in this case I think there won't be any problem. Even if you are updating or reversing or anything, that won't be a problem. Okay, so we can run this program. GCC for 9.c. Now if you compile run this, and if you run that is 245, you will get 11 as answer. 2 plus 4 plus 5. Okay, 5 plus 4 plus 2 will be done. Okay, so this multiple statements can be written in the third part or the updating part. Then another important thing, post increment, pre increment, and post increment and pre increment. So in the for loop, the third part we have already seen, we'll be including some post increment or pre increment, or post decrement or pre increment can be decrement can be done. So there is no difference if you are including that in the third part. But if you are including in the test expression part, then there is a difference. If you are including in the third part, then it is not at all an important thing. We will see an example, then you will understand that. Vim for 10.c. So this is the example. So here int I equal to int I is declared, then I is initialized to 0. Now I plus plus is done. So I becomes 1 now. I becomes 1 now, and after that printf hello will be printed. So this is actually infinite loop. Before coming into that, I will take another example. Okay, before coming into that, before this I will take another example. So we will use the first example for 1.c. So we have already seen that example. So in this case, so we have an increment operator here. So this is an increment operator here. This is post increment. So even if you make it as an if you make it as an just a minute. So it was I plus plus. We have already given it as I plus plus. Now if we are changing it to plus plus I also, there is no difference. So even if it is increment, post increment, or pre increment, so there is no difference when you are including this plus plus I in this part. Okay, so if you are including that in the third part, if you are making it the pre increment or post increment in the third part, then there is no difference at all. So then there is no difference at all. Okay, so if you run this program, also you will get the same answer. So I'll compile it. GCC for 1.c dot slash a dot out. If you run this 5 times, that hello world will be printed. So the thing to note is, even if you are making it as post increment or pre increment, there is no difference if you are making it in the updation part. If you are making it in the updation part, there is no difference even if you are including post increment or pre increment. Similarly, you can either include make it as post pre-increment or sorry pre-decrement or post-decrement. If you are using at I minus minus or minus minus I, both won't have any difference inside the execution. But if you are using some expression, pre-increment or post-increment here, then definitely there will be a difference. So we will see that example. So I'll call another program for 10.c. So this is an example for that. So here I is declared as integer, then I is initialized to 0. After that, what it will do? It will do this test expression. So here it is not a condition actually. So I is simply incremented here. I becomes 1. So I, after I becomes 1, what happens is here we will print this statement. Printf hello world will be printed. Okay. Okay, just a minute. Before that, I becomes, so here what happens is here prints nothing. Here nothing will be printed. We will run this program. After that, we will come to this explanation. So this is GCC for 10.c. We will compile it and run this. Then after that, we will see what happens. So if you see, if you run this program, nothing will be printed here. See, nothing will be printed. We have run this program and nothing is printed here. But we will see why nothing is printed there. So what happens is it is initialized to 0. I is initialized to 0. And what happens is I plus plus is done here. It is actually a post increment operator. It is post increment. So we have already learned post increment. So since it is a post increment, what happens is the increment does not happens there. So 0, I is 0 and 0 plus plus is done. Even though 0 plus plus done, I value is not changed. I value is 0. So since that I value is 0, after executing this expression, I equal to 0 means it is false. It is considered to be false. Any non-zero value is considered to be true. But since it is a post increment is done here, even though I is 0 here and it is I plus plus is done, after I plus plus is done, I is 0 itself. I is 0 itself. So this is actually a text expression. So I is 0. 0 means it is false. So printf this statement won't be executed, but it will exit this and return 0 will be run. That is, nothing will be printed. Here, after executing this, since it is false, it will come out of the loop. That is what is happening. So I is initialized to 0. Since it is post increment, I is 0 itself. After executing it, this expression, I is 0 itself. Since I is 0, it is considered to be false. So it will exit the loop. It will come out of the loop. So nothing will be printed or this updation won't be happening. So that is a main thing to be noted. Now we will see what happens if it is made a pre-increment here. Okay, we will make it as a pre-increment operator here. Okay, I made it as plus plus sign. Okay, now we will check what happens. So I is initially 0, I equal to 0. Now what happens? It is pre-increment. So since it is pre-increment, I becomes 1. So I equal to 1 means it is true. I equal to 1 means it is true. It is true. So printf hello world will be printed. After that I will be incremented again. I becomes 2. So I becomes 2. After that again it goes here. I becomes 3 here. Again printf hello world will be printed. Then I becomes 4. Again I becomes 5 here. Hello world will be printed. Like that it will go on repeating and this becomes an infinite loop. It won't stop its execution. Because initially I was 0 and since it is pre-increment, I becomes 1. Any positive number, it is considered to be true. So this is true. So hello world will be printed. Then again I will be incremented to 2. 2 becomes 3 here, hello world. 3 becomes 4 here, 4 becomes 5 here, hello world. Again 5 becomes 6, 6 becomes 7 here, hello world, like that it will go on repeating. So if you run this program, you can see that it becomes an infinite loop. GCC for 10.c. Now if I run this, you can see that it becomes an infinite loop. That is, hello world will be continuously printed. Hello world, it will go on printing it, because it won't be ending that. Okay, so this is another example. So post increment can be replaced with pre increment. In the case of updation part, or the third part, you can do post increment. You can make it post increment or pre increment. Similarly, if you are in the update part, if there is post increment, you can replace with pre increment. But when you do it in the middle, that is the second part, that is in the text expression part, there is a difference. Okay, that post increment and pre increment will have a difference when it is included in the second part of the for loop. Then it is not necessary that you should increment or decrement by 1. You can increment and decrement by more than 1 also. Where in the previous cases we have seen that I plus plus or only I equal to I plus 1 is done. It is not necessary only 1 should be incremented. You can increment to any number. Okay, I will show another example. Vim for 11.c. So this is an example. So here I equal to I plus 3 is done here. So I equal to I plus 3 is done here. So I is initialized to 0 here. 0 less than or equal to 9. It is true. So hello world will be printed once. After that I, it becomes 3. 3 less than or equal to 9. It is true. So again hello world will be printed for second time. Then I becomes 6. 6 less than or equal to 9. It is true. Then again hello world will be printed third time. Then 6 becomes 9. 9 less than or equal to 9. It is again true. So hello world will be printed for the fourth time. Then I becomes 12. 12 less than or equal to 9. It is false. So it will be exited. Okay. So if you run this program, GCC for 11.c. So if you run this program dot slash a dot out, you can see this 4 times it will be printed. Okay, since we are incrementing by 3, it will be incremented 4 times. Okay. Then any or all the 3 parts of the for loop can be eliminated also. So you can eliminate any or all the 4 parts of the for loop. So that is also possible. So if you are eliminating everything, you can eliminate all the things in the for loop also. So we will see an example here. So we will take the first program. We will see what happens in the hello world program. So what I am going to do is I am going to eliminate everything from the for loop. Okay. So I am skipping the initialization part, the third part, everything is removed. So only thing I have included is 2 semicolons here. Only 2 semicolons. All the 3 parts of the for loop have been removed. So what happens here? So if I am not including anything, what happens? So what happens is it will be an infinite loop. It will go on printing hello world, because it may we will check what happens. It will the usually this loop should run forever. We are not using anything. Okay, so let me GCC for 1.c. Now if you run this program, it should go on printing hello world. So it becomes an infinite loop, because that text expression is not at all checked, nothing, I value is not updated, nothing is done. So what happens is it will go on printing this hello world, because never that loop becomes false. So we can eliminate, we can omit all the 3 parts also in the for loop. Okay. So these are the different variations in for loop. So I have given some exercise also. We have already done this exercises in using while loop or do while loop. You have to convert it into for loop. These are all simple exercises. If you have know the logic of using for loop or while loop or do while, you can use the same thing here also. So program to find the sum of cubes of n natural numbers. 1 cube plus 2 cube plus n cube. You have to do this thing. Then program to find the sum of odd numbers up to n. That is 2 plus 4 plus 6 plus up to n. You have to find the sum of this. Sorry, it is not odd numbers. It is even numbers. So make it as even numbers. So I made it as odd. It is wrong. You make it as even numbers. Then program to find the sum of cubes of first n odd numbers, that is 1 cube plus 3 cube plus 5 cube plus 7 cube, like that you have to do. Then you have to program to reverse a number using for loop. You have to reverse a number. So if you are entering 245, then 542 should be printed. It should be done using this for loop. So all these programs should be done using this for loop. Only 4 programs I have given because we will be using this for loop when you study the next module and all. So in order to understand, try to work out all these examples, and also whatever I have included in the video, some 11 examples I have shown, you try by yourself. You have to try all those 11 examples and try yourselves. After that, you do this exercise also. Then only you will be you will thoroughly understand this for loop. So try all the 11 examples I have shown in the program. Okay, 11 or 12 examples I have shown in the video. You try by yourself. After that, you have to do this exercise. So that's all. Thank you.